You know, it's been over half a century since we last ventured out to the moon, but that's all about to change. We're on the very brink of going back. This is Artemis II, and it is a massive step on that incredible journey. Just think about that for a second. Deep into their mission on what they call Flight Day 6, the 4 astronauts of Artemis II are about to do something truly historic, a lunar flyby. This one single elegant maneuver, well, it's a pivotal moment that gets us one giant leap closer to actually walking on the lunar surface again.
So what's the big deal with Artemis II, really? Well, it's NASA's first crewed mission in this brand new chapter of space exploration. And this chapter, it's not just about planting a flag and coming home. We're talking about building a sustainable presence on the moon, all to get us ready for the even bigger journey to Mars. So the main goal here is pretty simple, but also incredibly complex. Send astronauts on a trip all the way around the moon and bring them back safely. It's about testing every single critical system on that Orion spacecraft before we even think about attempting a landing.
Okay, so the highlight of this whole mission, the star of the show on Flight Day 6, is the Lunar Flyby itself. The spacecraft is going to get incredibly close to the moon, but it's not going to land. Which begs the question, right? How exactly do you make a U-turn in the vastness of space to head back home? Well, the answer is this absolutely brilliant and elegant technique called a gravity assist. Instead of burning a ton of fuel to slow down, turn around, and speed back up, the spacecraft uses the moon's own powerful gravity to do all the work. It literally slingshots around it, changing its path and getting a speed boost for the long ride home. It's like cosmic surfing, using a wave of gravity instead of water. Just beautiful physics in action. Let me walk you through it. First, Orion flies toward the moon on a super precise path. They have to hit their marks perfectly. As it gets closer, you can just imagine the moon's gravity grabbing hold of it, bending its path, pulling it around. And then bam, Orion gets flung out the other side, perfectly aimed and moving even faster for its return trip to Earth. It's like this incredible cosmic ballet, choreographed entirely by the laws of physics. But you know, this mission is so much more than just a really cool physics demonstration. As Orion makes its closest approach, the crew shifts gears. They become a team of deep space scientists, ready to study our celestial neighbor up close like very few have before. They've got their eyes on 2 key targets, the Orientale and Hertzsprung basins. Think of it as a tale of 2 craters. Orientale is about 3.8 billion years old, and for a crater, it's incredibly well preserved. You can still see the dramatic rings from the impact. But then you have the Hertzsprung basin on the far side, which is even older. It's been battered and worn down by billions of years of smaller impacts. By comparing the two, the crew's observations are going to help scientists back on Earth understand the story of the moon, how its surface has changed over geologic time. And for the crew, wow, can you even imagine this moment? They will join a tiny, tiny group of humans who have ever seen the far side of the moon with their own eyes, a whole mysterious landscape that's forever hidden from our view here on Earth. Just an absolutely breathtaking and rare perspective. But here's the catch. That breathtaking view, it comes with a period of complete and total isolation. As Orion swings behind the moon, it enters a planned communications blackout. For 41 minutes, the crew will be utterly alone. No contact with mission control, no way to call home. It's a silent, solitary journey on the far side of the moon. So, as incredible as all this is, you have to remember that this entire flyby is the ultimate stress test. It's designed to push the Orion spacecraft and its crew to their absolute limits. It's all about making sure every single system is ready before we commit to actually landing on the moon again. On this one single day, they are ticking off some major boxes. They're proving the navigation systems are pinpoint accurate, even way out in deep space. They're testing the communication systems over these vast distances. They're making sure the life support can handle the strain of a long mission. And, just as important, they're assessing how the crew performs these complex tasks so far from home. Any little problem they find now is an absolutely crucial lesson for the future. And that's really the whole point, isn't it? The success of this flyby isn't just about this one mission. It's all about what comes next. Every piece of data they collect, every system they check out, it's all paving the way for our next giant leap.
You really have to see this in its historical context. It was 1972 when we last had boots on the moon with the Apollo program. Over 50 years ago, Artemis II is the bridge connecting that incredible past to an even more ambitious future. And that future is Artemis III. the mission that will finally land astronauts, including the first woman on the lunar surface once again.
So when you boil it all down, Flight Day 6 of Artemis II is so much more than a simple maneuver. It's a testament to human ingenuity, to our relentless curiosity, our drive to explore. It closes a long, quiet chapter in our history and throws open the door to a whole new era on the moon. Which really leaves us with just one final thought. To go that far, to see a side of a world that no one on Earth can see, and to just float in total silence on the other side. Would you take that journey?